installed in practical situations. A PVC window has been built into the test specimen and sealed using IZOLATIE. Instead of a butt joint, the tape is applied at the corners to form a loop. This helps to ensure that the corner areas are also completely sealed. Unlike similar systems, the IZOLATIE can be used on all 4 sides of the window frame, and it can also be used on a profiled windowsill. Before testing can begin, the ready-prepared test specimen is carefully checked by the engineer in charge of the process. For the tests that are to be performed, it's important that the sealing system be carefully installed and correctly mounted. The minimum testing requirement here is an A value of just 0.1 cubic meters per hour and per meter of joint length. Any localized sealing faults, for example in the corner areas, are not allowed. Next, IZOLATIE is tested for the resistance it provides against driving rain. Once the rainfall simulator has been turned on, 480 litres of water will be driven down onto the outside of the window every hour through 4 spray nozzles. The pressure is then gradually increased with a view to simulating the effects of wind and rain in natural storm conditions. Only when the outer sealing layer of IZOLATIE has been shown to be capable of withstanding the driving rain can the other features of the product, such as airtightness and thermal insulation, be guaranteed. Regular checks are made on the inside of the window to determine whether IZOLATIE offers sufficient protection against the driving rain. With the driving rain test passed, the first part of the procedure, testing in an as-new condition, is now over. And the result is clear. IZOLATIE stands up to wind and rain just as well as its manufacturers claim. During this time, IZOLATIE needs to demonstrate that it can stand up to the kind of everyday stresses that a window and its seal will be confronted with over the course of their working life. Key areas to take into consideration include stress caused by changes in the temperature, wear and vibration when the window is opened or closed, and stress caused by strong wind or suction, which can occur during storms. Sensors are attached to the window to measure stresses associated with changes in the temperature. Any movements in the seal caused by changes in the temperature will be shown during this stage. During these, the connection joints are subjected to dynamic shock loads. Around 10,000 operations are conducted during this part of the testing. All of those tasks simulate things people do with their windows every day, like turning, tilting and closing. When you compare the results of the first cycle and the last one, changes such as cracking, peeling, or changes in the color or the structure of the material. IZOLATIE